Hello, my name is Rez, and I'm a professional game programmer, and I do electrical engineering as a hobby. So we've got our circuit here. It works pretty well. I've redrawn it here with this schematic, so again, we can talk about what's going on. Now, the previous model, which I drew yesterday, still holds true. All of this is still correct. But for this section, just put this little blue line here. This is a different leg of the circuit. How does this work? Well, we've got this input coming in here. One thing about electronics is that we have this ground point. This is our reference. This is our sort of 0 volt reference. And it can become easy to look at things or talk about things with this as a reference. Because remember, everything is a differential. With voltage, you can't say what is the voltage at this point without some other reference. So in this case, ground is that reference. So what's the voltage at this point? Well, it's going to be based on ground. So again, all of this is what we had before is all what it was. So let's talk about what happens in the on stage. So specifically, this motor up here is on. And so in our view, that's when there's no light here. So if there's no light here, right, we get the conducting coming through here, we get it up here like this. Now, once again, we can think about this whole piece as essentially a single component, a single, giant transistor. So in this case, we need to look at the essentially impedance at this point, right? Because we're tapping off of this point. So in other words, what is the voltage at this point with reference to ground? Because everything again is referenced to this negative rail here. And is that enough of a positive pressure to pull the electrons essentially through this PN junction, that is, the P here and the N here, through this PN junction? Is it enough? And what we get here is we get approximately 0 volts, right? That's what we're going to get here, because this is essentially a short. This is essentially as if we just shorted this thing when this is in conduct mode, because this is fully on. We have this very powerful transistor happening here. And so we get, at this point, a very, very small amount of voltage. Not enough to actually conduct this thing. We'll get something like 0.75 is about what we were getting before, 0.8. So say that it's it requires 0.7 or so, and I think it's more than that, but I think let's say that it requires 0.7 to do this. Even that wouldn't be enough. It needs to have enough current going through here to actually try and bias this transistor. We're not going to get enough with this thing in conduct mode. Certainly not enough current to get this thing to start going. Now, if we switch this around and we make this an off mode, which I'll do again in red, what do we get? Well, we do have light coming in here at this point. And this light is essentially creating a short here. So it's as if I just, spliced a wire right in there. Thus, it's not going to have enough pressure. The voltage at this point, with reference to ground, is going to be quite small, almost non-existent. Thus, we do not have enough positive pull here to actually get through, the 1.7 volts-ish that we're going to need, 1.4 volts-ish that we're going to need to get through this junction, these two junctions here. So because of that, this transistor acts essentially as if it was just an open wire. Now that means no current is going to flow through here. We're going to have no current, but what we will have is a very significant voltage. We're going to have about 4.5 volts at this point. Thus, from here to here, we're going to have that 4.5 volts, 0.7-ish will be dropped here, and we'll have the rest dropped by this 1K resistor. Thus, this will be in full conduct mode. We'll have enough current flowing through here, and that will then allow current to flow through this junction, thus showing this motor. That's what's happening here. So that's how this whole circuit works and how these play with each other. And so based essentially on how much light is going through here, we're going to have one or the other going on. Now, an interesting question is about this transistor up here. Why is this not a Darlington pair? Well, it could be. We may be getting another transistor that will set this up as a Darlington pair as well. But basically, it has to do with how much current we can source. Same thing with this going here, right? We weren't able to source necessarily enough current from just the light going through. And we saw that, as I said before, in this previous circuit. We weren't getting a huge amount coming through. And I rebuilt the circuit on that day to make it better. We got more current flowing through this thing, even with this sort of pseudo Darlington configuration. It's not until we came to this day when we actually got enough of a boost. That's why we needed the Darlington pair here. Then we got the full brunt of this. Whereas here, we don't have to worry about that quite as much because this thing is biasing this. This guy can source the current that it should need, right? From this point here, we should be able to source it, but I could see us doing another Darlington here. However, I didn't see much of an issue in terms of not having enough oomph to it. We still get a decent amount of amplification, right? There's enough current here. And we can do the math on that if we want to, because remember what we have here, as long as the main power supply can source it, we have this guy who is dropping about 0.7 volts. So if we take our 4.5, which if this is an open switch, that's about what that's going to be dropping, over, or sorry, not over, minus 0.7-ish, that will drop here. We get the 3.8, divide that by 1K ohm resistor, and we get about 3.8 milliamps, about 4 milliamps total. So 3.8 milliamps with a beta of 100-ish or so, we should be okay there, right? We should get, I mean, we'll be measuring amps at that point. Even if it's a bit less than that, we're measuring quite a bit more. So this should be able to source enough current that it shouldn't be an issue. Whereas here we were running into issues with this guy. So that is why I think we'll probably be okay. I do wonder where we're going from here, where what the next thing they're going to have us build is, because we're starting to get closer to where we need to be. That's it. It's a pretty short technical video this time. I just wanted to talk about this leg of the circuit that we built, and we'll see what tomorrow brings us. So I will see you all tomorrow.